Hi everyone, we will now start implementing analytics service by adding a data access capability. I will start with data access package and create entity and repository subpackages. In entity package, we will create a base entity interface with generic type PK and define a getID method. Then create analytics entity that implements base entity with UID, and then annotate this class with entity and also with table annotation to set the name of the table Twitter Analytics. Then create the columns with column annotation and also with not null annotation. For ID, we also use ID annotation. I will use longbox getter and setter here as well as noarg and allarg constructors. But for equals and hashcode, let's implement it ourselves and use only the ID field in that, because ID is enough to compare equality of two objects as it is unique. You can also use equals and hashcode annotation from longbox here by configuring it to use only ID. Here we have a typo, this should be underscore instead of dash in the table name Twitter Analytics. Then we will create Analytics custom repository interface with generic types T and PK to customize the Spring Boot JPA repository. Here we define persist, batch persist, merge, batch merge and clear methods. We will only use batch persist for now, but it is good to keep these methods to be able to use them later. Then we create Analytics repository that extends JPA repository and with Analytics entity and UID generic types. And also extends Analytics custom repository with the same generic types. This way, we will be able to implement the custom repository methods and can use them with Spring JPA repository. Before doing that, let's add getAnalyticsEntities by word method here with query annotation and with a JPQL, that is JPA query language. That will get Analytics entity by word and order it by record date. This method takes a string word as param and also takes pageable param to be able to limit the data we query. Since there is no limit option on JPA directly, we use pageable here. And then we return a list of analytics entity. Then in the implementation package, we will create an analytics repository implementation class that implements analytics custom repository with generic type T that extends base entity and with PK. Let's also annotate this class with repository annotation to make it a Spring Bean. Here we define a log variable and then inject an entity manager with persistence context annotation. This way we can use the current entity manager within our custom methods, where actually this entity manager is a thread local reference to the entity manager object. We make this protected as we want to allow the subclasses to reach this entity manager in case needed. Note that an entity manager that is obtained with persistence context annotation is a container managed bean. That means we don't need to deal with transaction management or classing the entity manager. All managed with the transaction annotation. Here we get a reference to entity manager because we want to apply custom batching logic. We will do that to manually flash the data to database per batch size. Note that normally data only flashes to database when commit called. That means at the end of the transaction when commit called, data will be sent to database in batches. Alright, let's also get the JPA batch size config value using value annotation here. Then we implement the methods. For persist, simply call persist method and then return ID by calling the getID method. Since we use a generic type here with an upper bound to be able to get ID, we put a getID method to interface base entity. In batch persist, we will iterate over entities and persist each of them. However, when we reach batch size, we will flush and also clear the data using injected entity manager. This way we distribute the load during operation instead of flashing all of them at the commit time. And also we clear the first level cache so that we won't get trouble because of RAM is full. Here we also check if some entity left that is not flashed after the loop. As you see, these methods are annotated with transactional annotation, so transaction management, begin, commit and close handled by Spring. We do a similar logic in merge and batch merge methods. Note that for now we only use batch persist method among these methods. Lastly, for the clear method, we call the entity manager clear. Then we will create response model class, analytics response model with ID as UID, word as string, and word count as long. Then in transformer package we'll create two classes. One is to transform the Avro entity to database entity, which will be used inserting data into PostgreSQL. Here in this transformer we have used the ID generator, which is injected and used to generate a UID for the ID field on the table. For this one, let's create the ID generator bean on the common config module. which already has dependency from this Kafka Analytics service because of the Kafka admin dependency. Here for the implementation of ID generator, we use JDK ID generator from Spring library. And the other transformer is entity-to-response model, which will be used for the API of this service that will return the word count. Now in the Analytics Kafka consumer, we will inject Analytics repository and the transformer, and then call batch persist method after converting the list of Analytics Aura model object to list of Analytics entity objects. We also log info message before and after database persist operation. Alright, we finished the persist part. In the next section, we will complete Analytics service by adding a query part and controller to be able to call this service from query service. I'll see you in the next section.